Do you have one of these in your home? Every once in a while, I'll go by and glance in there and I can see now I need to put salt in it. Like, I don't want to be out here every week checking for the salt. There's gotta be a way home automation stuff can fix this. Yeah, let's stop checking this manually every once in a while. Let's build a device that can somehow tell when the salt's down and then notifies us. You know, it's not an emergency. We don't need the echo devices to scream at us. Let's think of ways we could monitor how much salt is actually in one of these. When it's empty, this whole column is empty of anything. Keep in mind also, it's humid in there, so any electronics we put in here are going to get wet. Let's think of something better that would let us know when the salt level has gone down. So we need something that is food safe, corrosion resistance, and on or off. I don't think we need levels. That's not important. Let's think about this for a second. Let's look through our bag of tricks. I keep my stuff kind of well organized when it comes to home automation stuff. So this is majority digital stuff. This is like LEDs, screens, little on-off buttons, hall sensors. This is no like a lot of gates that I maybe on the phone. This is pretty neat. Let's see. I got motion sensors and LiDAR and computer player. I showed you that today. Type K sensors for temperature on the top. But yeah, cool. Still motion sensors are really small, and they communicate almost over USB through devices like I2A or I2. And then some switches that have a little ramp on them. How about let's put something on here that's heavy, and when the salt is low enough, it pulls that down like that. That's a switch that could do that. I think we're going to use one of these. Somehow we'll mount it to the lid, and then we'll have our and you know, fishing line is probably also non-toxic and non-corrosive. So all we need now is something that will weigh it down without contaminating the water. And I'm not saying that our drinking water is in there. I'm just saying that anything in there probably shouldn't be capable of contaminating drinking water. So that might be fun someday. Let's see. These are really small ESP devices. Look how tiny those are. It's only that big. So those are tiny ESPs. These are the ESP32. But guess what these are? These are casting weights for practicing fishing. It's almost like I've already done this once and I'm making a video about it. Well, this would probably work perfectly. So let's say we've got our switch, tie a string, and we put one of these on the other end. It's heavy enough to make the switch go, I hope. That one's not. Well, that one is. Where did this come from? Okay, this was just legit in my box, but apparently I was already planning to do this. I've got string, I've got a lead weight, or not a lead weight, some kind of plastic, and it's plenty heavy to make that fall. Okay, I think this is our setup. So whether or not we use this one's probably in good shape. It's already got some wire on it. It's almost like I was planning to do this on the second one. And now we're going to make a video out of it. So let's do it. Sounds like a good idea, right? Very little code. We're just monitoring a binary sensor is all that is. On or off, it's binary. This is going to be fun. I'm excited for this one. You'll get to see me put it all the way in. I think we're just going to hot glue the switch to the lid and drill a little tiny hole. That's how we'll keep the humidity inside, and hopefully the switch will live a very long time because it's in the more dry air above the lid. So as I mentioned earlier, I'm actually interested in using one of these really small ESP devices, simply because they were very inexpensive, and I bought 10, I think I bought 20 of them for under, I think, 15 bucks or something, and I have a bunch of them. So if we can make use of them, we may as well. So this is the chip, and then it's got all of these ports My goodness. A messy workstation. Who would have thunk it? Trim it. Done. Okay, that's all we had to do to create our temperature sensor, humidity sensor, and salt level sensor, which is just a switch. So I hope I've been in frame the whole time. So there's our everything and the chip. So next we got to do is program it, adopt it into a network. So we've soldered it together. I went ahead and put the base image of the ESP home software on it. I haven't coded anything yet, but let's go install it on the salt container in the basement. That's where it's going to live, and that should be easy to do. So let's go do that real quick. The first thing we're going to do is drill a hole in the lid. About in the center ought to work. Whoops. I was trying to push kind of hard so that the plastic would just come out in 2 long strands instead of powder. Apparently this drill bit is not sharp at all. But we got a hole, and that's all we needed. And I don't see any plastic in there. Okay, the next thing we need to do is mount the switch. And we need to mount the switch so that if there's ever any string, it goes straight down the hole without touching stuff. So let's bring the switch and the little circuitry stuff with us in here. And it should be pretty easy to eyeball this, but at the same time, we could also just stick this through here real quick and tie a quick knot. Maybe. I don't drop it all. I'm also giving my hot glue gun a chance to warm up because I just barely plugged it in. Caught me a lot of fish with a granny knot. Probably shouldn't be admitting to that. All right. Now let's see where our hot glue gun is at. And like I said, it's not critical. We want to get it so that our line is not bumping up against the side of the lid, the hole we made in the lid. So we'll just start with a little mound. Let that cool off for a second while we hold this guy in place. Maybe drag that stuff around and make sure that that fishing line is right where we want it. Okay, that started to cool. So let's give it another glob. Both sides is a good idea. And again, let it cool. I think we're almost done. Nope. As you put new glue on, it warms up the old glue, apparently. Bet we can speed up the curing process here, or the cooling down. I help a little bit, right? Oops. There we go. I probably should have let those lower thick areas cool off before I had added any. That ought to cool it right down. Yeah, pretty sure that's not in the manual of things you're supposed to do, but if it works, it works. All right, that completes the installation of the switch. We still have some code to write and then some automation to plan. But for the moment, I like where we're at. And thankfully, I have an example of doing this before, which means so do you. So if you're going to do this in your home on your water softener, you don't have to code it yourself. You can just copy mine. As for the device, I think a short USB cable between here and this outlet up here will be perfect, with plenty of room for the connector. Actually, I guess we need at least a foot. So let me find that. And then the last thing we have to do is calibrate the distance of the fishing line, because that will tell us when the alert says, hey, we need salt. So let's look at that right now. Right now, that is not very long at all. So let's completely disconnect that. I think we want to start from scratch. Oh, still warm on the bottom. Oh my goodness, they were under the volt ohm meter. All right, so first thing we can do is let's nip this off of the weight. We're going to put a brand new line here. And all I can find is 4-pound leader. So let's hope this thing never weighs more than 4 pounds. Oh, that's hilarious. I don't have any 4-pound leader. All right, please hold. Leader accomplished. Still 4-pound, but I think it should be fine for what we're using it for. So we'll just send a little tiny knot through here, tie a knot, take the end around the weight. Okay, that's down. Now, how far down do we want it to go? Go back just a little bit. I think the water line is about here. So I think about there is where we want it to end. So let's nip it a little long and then we can adjust it. Okay. So we can put the spool of wire or line down. We can, let's see, we want to pull the old stuff out. And then we want to send the new stuff through. Yeah, that's a nice little tiny hole. Hopefully we won't have any like evaporation or humidity leaking or anything like that. Okay. I think I'm going to set this like that. Maybe not. How about we land this on that thing. There. Okay. Next step is to disconnect. Oh, I got a little cute swivel. Okay, let's just see if we can do the swivel. Okay, that is a small, little itty bitty tiny baby swivel. And we'll just trim that off. Nice and clean. And then let's do the same knot, because we're going to want some of this line taken up. Okay. Excellent. And now place it on there. That's the most complicated part. Okay. So if the lid is on here, it's about where I want it. Yeah, that works. Okay. Let me go grab a charging cord and I'll be done in a second. All right, so I've got my power. I've got my chip. Let me make sure we didn't mess up the wire. Since it's 2 individual wires, I just want to make sure that they are loosely done there. Okay, that's good. So we plug this in first. Plug that in second, and hopefully there's a light that we'll see when that comes on. Yep, I saw a little tiny blue flash. Set this kind of out of the way, right there where all that water is likely to be in the future. Let's twist this. And when we plug this in, I think I want some pliers to smash those connectors better. So I'll do that in a minute. But anyway, this completes the physical world stuff. Manual switch. When salt is present, this will be high. As the salt runs out, eventually that'll drag low. Oh, it's not inside. That's where that was rough. Oh no. We made it too long, I think. It's at the bottom, or it's in water and it's floating. So we'll have to shorten that a little bit so that it's tugging, but I can do that offline. This setup is done. The rest is going to be done in software. So let's switch gears and do that. I ended up trying to deploy the chip the way I had soldered it, and when I was installing the code on it, it would not pick up my temperature sensor. And then I thought about it for a second, and I realized that all of the other ones that I did, I used a full-blown 8266 chip, and maybe the support for that I2C protocol is better, and I just decided not to waste my time on it right now. So we are down to only 2 leads coming out of this device, and I also had to change the decision on which 2 leads to do. I hopped over to the other side of the chip with one of the leads, and then I'm connecting to ground instead of hot. So rather than sending 3 volts to a pulling up pin, I'm sending ground to a pull down pin, something like that. Anyway, it's working a lot better. So this now became simply a wire with a switch, and now it's remote. So let's try it. We're trying to keep this super simple. Let me show you the ESP home config that I did to flash onto here, so you can see that it, when you pare away all the Wi-Fi config and the MQTT config, it's really simple. It's a binary input, yes or no. And then we'll go downstairs. I'll show you it in action, and then we'll be done. This will be a nice video. So that's the update. Okay, on the right side of your screen here, you're seeing my ESP home configuration. Up on the top, whenever I try to reuse code somewhere, I try to include a substitution block up on top. So these are the things that I'm going to use later in the code so that I can copy the code that's down below without having to make, find and search and replace things. So these are just variables, things that we're going to change around. And some of them I might not actually need. Like, for example, I no longer need that one. But basically what I'm doing is I'm establishing what the name of the device will be when it's being edited in ESP Home. Then this is the host name. And then this is for my own personal use. I'm just saying where it's on my property. Then we're saying this is an ESP Home chip. It's the ESP12E, which is this small little chip I'm using. Turning on logging, saying I want over-the-air deployment, saying I want a web server, which is not always necessary, but I love being able to ping and get onto my little devices. This is my Wi-Fi configuration, and these are some of the reasons I love ESP Home. I've got the ability to set these timeouts. And so if this device can't maintain a Wi-Fi connection and it's continually trying and it still can't, after 30 seconds, it's actually going to reboot the little chip. So if for some reason while it's trying to get Wi-Fi it can't, rather than getting ever into a loop that we don't want, it's just going to reboot the machine. If it can't ever get the Wi-Fi, it creates this fallback, which, with the reboot timeout, this might be kind of useless. Portal is lets me connect to it when the Wi-Fi fails, but I got a feeling again that this reboot timeout is going to basically make these useless. And then my MQTT broker is sent these values here. Once again, if I can't get to MQTT within 30 seconds. I'm going to reboot the whole machine. Now to the actual useful things. As always, I like to include a sensor, which is the Wi-Fi signal. Someday my goal is to plot these on a picture or a map of my property so I can see where things are getting good signal and where they're not. It's free and easy to do, so I send it. The last thing is our binary sensor. It's up or it's down, true or false. And what I had to do was tell it that it's a GPIO type. I told it which pin it is, told it that it's an input and that it's pull up. So whenever it's not grounded, it's going to be high. And that's what pull up does. And then this is kind of cool. The switch that I installed downstairs, it's one that I had used previously, set up for this, but I didn't do it the exact same way I did in my garage. And I was getting the reverse of what I wanted. When it was saying that it's full of salt, it was saying it's empty. And when it was saying it's empty, it was saying it was full. And so this is so cool about ESP Home. I just said inverted. And so because this isn't the super high priority stuff that I built other chips to handle, just let the software say, oh yeah, it's inverted. Really, really cool. Gave it a name and an ID, and then installed it. And since I have flashed it from the computer at least once, I can now let this process just happen over the air, over the network. And it's pretty slick. There it goes. Since almost nothing changed, it just uploaded the code and it's done. And so now I can visit the website. I refresh to make we're still there. So you can say here, hey, we're getting an update. It's going to want to refresh at least once. There we go. So my low salt signal is on, and that's true. I have not yet put salt into that bin downstairs, so it's totally normal that that would be on. So that's basically what we're getting on the web server of that ESP Home. What we're now also getting is information into our MQTT broker. And if I highlight on the one that I'm interested in, you'll see its state is currently on. I think we should go put salt in the bin down there, and then we can come up and see if the state has changed to off. And then that's good enough. I've got other home automations that I'll pin it into, but that's what this video was, is how to get from a super inexpensive chip, like 10 of these for $8, I think, to a monitor on your home network somewhere. So let's go put some salt in, and then we'll see if that thing has changed. And now for the final step. Set the weight on top of the salt. Got to make sure that your line isn't bound up on anything. And then plug it in, and let's go check our sensor, see where we're at. I'm just letting this thing kind of float in the air. Certainly a 3D printed case could be made for that. Probably do that a little bit later. But the goal of this video was super, super quick, super, super cheap. And I think we've got there. And exactly what we were hoping for. The state is now off. I get a cute little history over here where it was on for a long time and now it's off. So what I want is a rules-based engine that will tell me somewhere visually that my salt needs to be filled up. And I am no longer sure that OpenHab is the right choice for me. I think I need to do a really good look at Home Assistant. Some friends use it. They don't use OpenHab at all. I've been using OpenHab for a long time, but I don't know that I'm using enough of it to warrant such a big, expansive system. And Home Assist might be just what I need. I need light switches and a couple of rules. Things like watering the lawn seems simple to me. So I don't want to go into OpenHab a whole bunch. I don't want to talk about installing it from scratch and building it up because I am not sure I'm going to continue using it. So that's why this video is going to stay between the ESP Home and MQTT. Those are the two systems that get information from the real world into technology world, into bytes, ones and zeros. So that's it. Thank you very, very much. If you have questions, please ask them in the comments. I have some more to learn too, apparently. I thought I could use a nice I2C on these little minis and it didn't work. So, you know, we're never done learning. So thank you very much and enjoy the rest of your day, I guess. Bye-bye.